So hello and welcome to all students. So this is FY BSc class semester second, mathematical and statistical techniques second. So and in this unit number 2, derivatives and applications. So in this lecture we study a new point, and that point is extreme points. Extreme extreme points. Okay, so extreme points means either maximum or minimum points. Okay, a curve is said to have an extreme point if it attains either a maximum or minimum in the minimum in the domain of in the domain. Okay, for example, see here, suppose we have a curve. Let us try to draw a one curve. Okay, suppose see here. Okay, suppose this is xy plane and the curve of the function, suppose this is the curve of the function, and therefore the maximum point, peak point of that curve is here. Okay, and the point on the x-axis corresponding to that point is called as the point of maxima. This point, okay, is called as maximum. Okay, just write here maximum. Okay, and the value corresponding to this point is called as maximum value of that function, and that value is corresponding to this point. So this value is called as the maximum value, and as this value occurs at this point, therefore this point is called as point of maxima. Okay, now consider the second curve. Let us consider the second curve. Suppose my curve is like this. Okay, then so this point is a point of this point on the curve gives minimum value of the function, and that minimum value occurs at this point. That value is called as a minimum value of the function, and the point on the x-axis, so the x-axis, this is y-axis, we know that the point on the x-axis corresponding to this point value is called as a point of minima. 1 minute, what I have written here is maximum. Okay, yes. Okay, minimum, just I want to write here a minimum. Okay, that point is called as the maximum value of the function, and this point is called as minimum, point of minimum, point of minima. Okay, point of minima, maximum value. Okay, so we have some results corresponding to this. Let us write first result, some results now. Result, first result is, and these results are very much important while solving problems. Okay, first result is, if f is a function such that if f is function such that f dash at a is equal to 0, and second derivative of function f at point a is less than 0, then the function f has maximum at x is equal to a. Then, that is important, then function f has maximum then function f has maximum at x is equal to a, full stop. Okay, similarly we write the second result if f is a function such that f dash at a is equal to 0 and f double dash at a is greater than 0, then function f has minimum at x is equal to a, has minimum at x is equal to a. Okay, so before solving the examples, let us state the procedure to find the extreme values. Okay, so let us go to the procedure which explains how to find extremum and maximum or minimum values and extremum and maximum point. Okay, now let us write the procedure. In the step 1, in the first step we find f dash of x. Okay, in the second step put f dash of x is equal to 0 and find values of x, find roots. Okay, in the third step find second derivative f double dash of x. Okay, and in the fourth step check f double dash of x for above values of x, and here is the main part. And here if f double dash at x is less than 0, then corresponding x is the point of maxima, then x is point of maxima, maximum. Okay, second, if f double dash of x is greater than 0, then x is point of minima or minimum, point of minimum. Okay, so based on these results, let us try to solve some examples. Okay, so let us write the question number 1. Question number 1 is, right, find the extreme values of the function, find the extreme values of the function f of x is equal to 2 times x cube minus 15 times x square plus 36 into x plus 5. Find the extreme values of the function, comma. Okay. Also state the extreme values of f of x at the corresponding points. Find the extreme values of the function. Okay, no problem, we will find the extreme values. Let us write the answer of this question. Okay, so first of all, we write the given function f of x is equal to 2 times x cube minus 15 times x square plus 36 into x plus 5. Okay, so this is given function, and we go step by step. In the first step, we write f dash of x, means the derivative of f with respect to x. So we write the derivatives of each term by using the rules of differentiation. So as 2 is constant, we keep as it is, and derivative of x cube is 3 times x square minus 15 is constant as it is, derivative of x square is 2 times x plus 36 is constant as it is, and derivative of x with respect to x is 1 plus, as 5 is only a constant term, its derivative is 0. So in the first step, we have f dash of x is equal to 6 times x square minus 30x plus 36. Okay, so this is f dash of x. Okay, so in this second step, we find the roots of the equation f dash of x is equal to 0, that is 6 times x square minus 30x plus 36 is equal to 0. So just divide by 6 and we get x square plus divide by 6, so here is 1 x square, here will be 5 times x, and here will be 6 is equal to 0. Okay, and this is the quadratic, left hand side is a quadratic polynomial, and its two roots are x minus 2, x minus 3. These are the two factors on the left hand side. Therefore the product of these two brackets is 0, means one of them must be 0. Either x minus 2 is equal to 0 or x minus 3 is equal to 0. So from this equation we have x is equal to 2, or from this equation we have x is equal to 3. So these are the two roots of this equation. Okay, in the third step, what we have to do is, in the third step we find f double dash of x. So f double dash of x means it is a second derivative of f, means derivative of first derivative is called as second derivative. So d dx of first derivative. So what was first derivative? And it was 6 times x square minus 30x plus 36. Okay, and it is equal to 6 times x square, so it is derivative 6 as it is, and derivative of x square is 2x minus 30 is constant as it is, derivative of x is 1 plus derivative of 36 is 0, because 36 is the only constant. Okay, it is 12 times x minus 30. So this is our f double dash at x. Okay, now in the fourth step, we will find f double dash x. Find f double dash x at x. Okay, so at x is equal to 2, f double dash at 2 is equal to 12 into 2 minus 30, and it is equal to 24 minus 30, and is equal to minus 6. So in this case what we got is f double dash 2 is negative. Okay, is negative means less than 0. So this implies that the point x is equal to 2 is a point of maximum, is a point of, I will change the color to write that word. Okay, is the point of maximum. Okay, and the maximum value of the function is the point of maximum. And next we write the maximum value of f is f of 2, and it is equal to f of 2 means 2 times 2 cube minus 15 times 2 square plus 36 times 2 plus 5, and it is equal to, it is 16 minus 60 plus 70, no it is not, it is 72, I think. 72, it is 72 plus 5. Okay, and it is equal to, what is 16, here will be plus 12 plus 5 means here is 33. Okay, 33 is the maximum value of that function. 33, is it correct? I think it is not correct. Okay, 3 square. Okay, 33. Yes, it is correct. 33 is the maximum value. The maximum value of f is 33. Okay, now let us check the same thing for the next point. We write here now, put x is equal to 3 in f double dash of x. Therefore f double dash at 3 is equal to, f double dash at 3 is equal to 12 into 3 minus 30 is equal to 36 minus 30 is equal to 6, and it is greater than 0. Therefore f double dash at 3 is greater than 0, and this implies that from the above result, this implies that f x is equal to 3 is a point of minima, is a point of minima, and therefore the minimum value of the function is f of 3, and it is equal to 2 times 3 square cube minus 15 times 3 square plus 36 times 3 plus 5. Okay, and it is equal to 32. So this is the minimum value of the function f, and it occurs at point x is equal to 3. Okay, now let us go to the let us give some homework for you. Let us try to solve these questions at home. Homework. Let us write first question for homework. Try to solve this question at your own. Okay, find the extreme values of the function. Find extreme values of function. Find extreme values of function f of x is equal to x plus 1 upon x. Okay, so try to solve this question at your own, and this is the end of our lecture, and thank you for paying attention. Thank you very much.